Difficulty index. As items difficulty index is obtained by calculating the p-value. P, which is the proportion of students answering the item correctly. So before we're going to compute, we have here a formula in getting the proportion of the students answering the item correctly. So in getting the difficulty index, we have the formula P equals R over T, where P is the difficulty index, R is the total number of students answering the item right, while T is the total number of students answering the item. So it will become P equals R divided by T. So we have here two illustrative samples. So in item 1, there were 45 students in the class who responded to item 1 and 30 answered it correctly. So we use the formula P equals R divided by T. So P equals 30. 30 is the R, which is the total number of students answering the item right, divided by 45. 45 is the T, which is the total number of students answering the item. So 30 divided by 45 equals 0.67. So item 1 has a p-value of 0.67. 67% got the item right, while 33% missed it. So when you're going to convert 0.67 into percent, it will become 67%. And the rest, which is the 33, is the student who missed it. And we have also here the item 2. In the same class, only 10 responded correctly in item 2. So we use again the formula, which is P equals R divided by T. R equals 10 and divided by 45 is the T. So 10 divided by 45 equals 0.22. So item 2 has a p-value of 0.22. So out of 45, only 10 or 22% got the item right, while in 35 or 78 missed it. So for normative reference test between the two items, item 2 appears to be a much more difficult item since less than a fourth of the class only was able to respond correctly. While for criterion reference test, the class shown much better performance in item 1 than in item 2. It is a long way for many to master item 2. The p-value ranges from 0.0 to 1.0, which indicates from extremely very difficult, as no one got it correctly, to extremely very easy, as everyone got it correct. For binary choice items, there is a 50% probability of getting the item correct, simply by chance. For multiple choice items of 4 alternatives, the chance of obtaining a correct answers by guessing is only 25%. This is an advantage of using multiple choice questions over binary choice items. The probability of getting a high score by chance is reduced. Discrimination index. As earlier mentioned, the power of an item to discriminate between informed and uninformed groups or between more knowledgeable and less knowledgeable learners is shown using the item discrimination index. This is an example item statistics that can reveal useful information for improving an item. Basically, an item discrimination index shows the relationship between the student's performance in an item. and his or her total performance in the test presented by the total score. So item total correlation is usually part of a package for item analysis. Getting high items total correlations indicate that the items contribute well to the total score, so that the responding correctly to these items gives a better chance of obtaining relatively high total scores in the whole test or sub-test. Discrimination index have three types. The positively discriminating item, which is the proportion of high scoring group is greater than that of the low scoring group. Negatively discriminating item, it is the proportion of high scoring group is less than that of the low scoring group. Lastly, not discriminating, it is the proportion of high scoring group is equal to that of the low scoring group. Calculation of the discrimination index therefore requires obtaining the difference between the proportion of the high scoring group getting the item correctly and the proportion of the low scoring group getting the item correctly using the simple formula. D equals RU over TU minus RL over TL, where D is the item discrimination index. RU is equals to the number of upper group getting the item correct, while the TU, it is the number of upper group, while RL, it is the number of lower group getting the item correct. TL equals the number of lower group. So we have here another formula which can bring about the same result. D equals RU minus RL over T, where RU equals the number of upper group getting the item correct. RL equals the number of lower group getting the item correct, while T equals number of either group. So it will become D equals RU minus RL divided by T. As you can see, R over T is actually getting the p-value of an item. So to get D is to get the difference between the p-value involving the upper half and the p-value involving the lower half. So the formula for discrimination index, D, can also be given as D equals PU minus P1, where PU is the p-value for the upper group, RU over TU. P1 is the p-value for lower group, RL over TL. To obtain the proportions of the upper and lower group responding to the item correctly, the teacher follow these steps. First, score the test papers using a K to correction to obtain the total scores of the students. Maximum score is the total number of objective items. Second, order the test papers from highest to lowest score. Third, split the test papers into halves, a high group and a low group. So for a class of 50 or less students, do a 50-50 split. Take the upper half as the high group and the lower half as a low group. For a big group of 100 or so, take the upper 25 to 27% and the lower 25 to 27%. Maintain equal numbers of test papers for upper and lower groups. Then fourth, obtain the p-value for the upper group and p-value for the lower group. P upper equals RU over TU, and also P equals RL over TL. So in fifth, get the discrimination index by getting the difference between the p-values.